Hello everyone, welcome to another episode. In today's episode, we will take a look at window functions. And window functions are functions that process group of rows. And for some reason, my colleagues and I really like to ask questions about window functions during interview. And I think the reason for this is not a trivial topic, but this is a topic that, if you know, can help you to significantly simplify many analytical use cases. And this is why it's good to know them, and it also shows that somebody did a little bit more than few basic SQL courses. Okay, so without further ado, let's jump to our data. And I'll not show you all the analytical functions, window functions. Oracle defines them as analytical functions sometimes. I'll not show you all the window functions because this has never been a point of this series. I'll just show you the concept, and I will show you the best or the most important use cases. I'll show you a few examples, and then I will also say to you that sadly, different DBMSs do support different window functions, and I would expect that there are some syntax differences between DBMSs. So I'm going to present you the general idea, but be prepared that you need to jump into the documentation of the DBMS that you are using, so like Oracle, DB2, Postgres, MySQL, and so on, to be able to use them precisely and as you want. So first, we are going to be working with our test table. So this we have generated in the previous video from this series. I will now show you a link on the screen. I'll just select everything from this test table that we have there, and that's a good start to forget with your from. I just modified it slightly so that it has 1 million rows and not 10 million, so that our queries don't take forever. By forever, I mean few seconds, but still. If you have to wait, it's kind of annoying. Okay, first off, let's try to select a sum of y, right? And we already know how to do it. It's pretty straightforward. You say select sum of y from test table. And we have a sum of y, it's a big number. I'm not going to attempt to read it. However, what if we wanted to have it in a row? Because let's say that we want to calculate. Basically, if I now select every y, right? So I select, let's say here, every y from test table, right? Here I wanted to calculate, okay, how much or how big of a percentage each y contributes to the total sum, right? So what I would need to do is, and here I would use like a subquery, I would need to say, okay, I will select y, and here I select y divided by, I will open the closed parenthesis, and inside these parentheses, I would copy this query, put it right here. Make sure that tabs are somewhat aligned. Table, and I will execute this. And now I have, okay, here, these are very small numbers because like there are a million records right here. However, we can see that we have achieved this. And here you can see that even with such a simple use case, it's getting kind of lengthy, in my opinion. And here is where window functions allow us to do it much easier, much simpler. Because if you want to do it with a window function, all you need to do is you have to select y, and here you say y divided by sum y from test table. And this for now will not work, right? It will say that not a single group by function, because by default it thinks that we want to do a ordinary group by, right? So the y, and then it treats it like a normal aggregate function. But we can say over, and for now I'll keep here an empty parenthesis, and I will execute this. And now what you can see is that we have the exact same result. So if I execute here, the first record, you can see is like 137758, and here, whoops, and here 00137758, right? So it's exactly the same. So, and already here you can see that the results are much simpler, much shorter. But this is not, I think, the main use case of it, because if this was, yeah, well, this is, to be honest, super simple. Wouldn't be literally worth the effort. We also have touched multiple times in this series on a case where we have the group by, right? So in this table, in this test table, we have like fruit, color. And we also have, let's say that we want to sum y, and we want to say from test table. And now we do an ordinary group by, right? Group by fruit and color. And we execute this, right? Here I don't have a comma. And we execute this. And now we can see a sum in each of these groups. So we have 16 groups, right? 4 unique values in each column. We have 16 groups in total. We have here a sum of y from each of these groups. And now if we wanted to do a use case as we did here, right? So we wanted to check, okay, how much each y contributes to the actual sum here. We would need to do something that is, in my opinion, slightly complex, because what we would need to do is, I will now try to do it. We would need to select y, fruit, color from test table. I will already assign an alias here. Then I would need to left join it, and I will need to open close parenthesis. So I'll just copy this part that I have up here. Here I'll just copy it. And this is our subquery. So basically on subquery equals, or subquery.fruit equals test table.fruit, and subquery.color equals test table.color. Okay, this will be all, but I need to here go ahead and say that this comes from the test table, this comes from the test table, and this comes from the test table. And now what I will need to have here is I will need to do y from test table divided by the sum of y, and let's here give it an alias. So let's say as sum y. And so I'll do y, y from test table is divided by sum of y's from the subquery. And here I process this. Now we have a different ordering. Or no, I think here we still have the same y at the top. But here you can see we have generated exactly that. So now we see, okay, how much or how big of a percentage each y contributes to the group sum. And now you can see that now it's getting kind of lengthy, right? We have this join and it's all complex and difficult. So now, you probably guessed it right, we will do it much simpler. And now you'll see the difference and basically the power, right? Because you can easily imagine could create here like subgroups and treat this fruit as a group, color as a group, and then have a subgroup, or like a orange-green group, and then let's have some subgroups in between. This could get like really complex very quickly. So let's take a look how we can do this with our new window functions. So let's select y, fruit, and color. And then let's select y and divide it. So now open close parenthesis. And here what we do is we do sum y, this we already know. We know that we need to do over, we need to open close parenthesis. And now I will say partition by fruit and color. And I will just say from test table and execute it. And the ordering has changed now currently, but we have a result. And now you see basically we have this compared to this. Much simpler. So what have we done and how basically the window function is defined? It's essentially defined by the over clause, right? So you saw that if I didn't have the order clause right here, it was treating this as a standard aggregate function and it was expecting a group by. Therefore, it has even showed us an error. And currently, we have the over clause, so it knows, okay, the interpreter knows, okay, this is a window function. Therefore, we can also make use of this partition by. And the partition by, at least how I imagine it, it groups together rows, and this is the window where the function will be applied, where this function will be applied, right? So it has like, now it creates 16 groups because we have 4 unique fruits, 4 unique colors. So we have 16 groups, and basically in each of these group, it takes all the rows and applies the sum to all the rows, to all the 16 groups separately. Much simpler, much easier. But it's not the last use case, or of course it's not the only use case. What you also can do is you can work with row numbers. So basically Oracle by default, I'll now select, I don't know, XY, fruit, color. Basically I have moved to this each value in a new line where I have like because now we are working with difficult expressions and I just like to have them in separate lines. I think this makes it a little more readable. So now let's take this. I will take actually this part right here. Let's maybe return a sum first, right? So you'll once again have a sum of all the of the y's, right? So of the y's, and here we say from test table. And now let's think about that. We would like to return to us an order inside each group. We would like to have the X results ordered, right? So from the smallest to lowest, but inside each group. So what we would do is we can come in here and we can just say order by Y. And just like that, we have the results ordered from the smallest to the lowest. And I don't know if you have now noticed what happened. With us introducing the order by, because you could have asked, and this would be a good question, okay, why do I bother and put the order Y in here when I could just put the order by in here, right? And I could just order by like fruit, color, and Y, and the result would be exactly the same. But now, if you take a look at what happens to our sum function, you can see something very interesting. Now it has become a cumulative sum, right? So we can see that the sum for the first row is 5, while definitely not the sum in the whole apple black group is 5. You can see here 85, so 80 plus 5, 174. So 80 plus 89 plus 5. This all matches, and this matches all the way down here, right? So we have just created, by introducing this order by, a cumulative sum. So I can just save it as cumulative sum, just like that. And this would be difficult, if not impossible, without using this window function. This is a very useful case, I think. What else I can show you is we can also generate a row number. We can also row number, and then I can copy this part right here. And now what we will have is essentially inside each group will have it starting from 1 once again. We have a number of a row in this group. We can also here order by something different. We can, let's say, order by X. And here we can have it ordered by X, while still we can here have the cumulative sum of Y, right? And here you also can see now that the row numbers are ordered by X. And here I can, for example, change it by Y to Y. And here now what you will be able to see here is, okay, this value for this lowest X is 7,566 value, highest Y value, right? So a little bit convoluted, but here you can basically play around with it, run a few examples on your own. Now, in order to show you the next few examples, I need to select a subset of the data, right? So I'll just select X, Y, fruit, color from test table, where Y between 1 and 20, let's say, order by X. Okay, I don't need the order clause, but what I wanted to show you is I wanted to have a few values inside of Y which actually do repeat. And here inside of the green, you can see we have 4 2 times, right? So we have green and then here 4, and we have green and 4. Because what I'm about to show you is essentially we are going to play with row numbers, but slightly different. So let's say that we want to select Y. We want to select the color. Oops, only one U. And then let's stick to our sum, right? Just for the sake of it. So we stick to our sum. We once again have over and now partition by. I will only partition by color, just so that I have a few the same Y values inside one group. And let's order by Y. So we have once again the cumulative sum. right? So here we can give it an alias. It's good to give an alias. I think I already mentioned this in the previous videos when you have like an expression, because then the name of the column in the result set is actually somehow relevant. And here, let's use our row number function, right? So we'll have row number over, and essentially the same thing that we have right here. So I'll just copy this. And let's stop. Right here, I will now execute this part. So what we can see is we have the color black, right? We have some values, and we have a row number, which is right here on the right-hand side, and we have a cumulative sum, nothing new. I'll now copy this thing, this thing that we have right here, and I will replace a test table with it. So I will open close parentheses, make sure the tabs are aligned, and I will execute this. I'm doing it just to have fewer results so that I can actually show you in between groups that it actually works, right? So here we have the black group, here we have the blue group, and here we have the green group with the 2 4s that I have showed you, and I would like you now to pay attention. Maybe I will what happened to here, right? So here we have 1, 2, 3, 4, 5, 6. So even though the 4s are exactly the same in terms of value, here we have a different number. If you wanted to change it, right, and you wanted to say, okay, like what's the value from the biggest, right? So let's say that you want to know, like, okay, 4 is second biggest or second lowest, in this case, value in this data set. By the way, if you want to make it show the biggest values, you just say descending, right? I'll currently rerun this. You can see now it's instead of let's find a green, we have it from the biggest to the lowest, right? So it's a fourth. We have 2 4s, and 4 is the second lowest value. What do you do now? You do something very, very simple. You just say rank instead of row number, and then you copy the exact same part that you have right here. You put a comma here, and you execute this function. And if we go to our favorite green, we can now see we have 1, 2, 3, 4, 4, 6. And I have actually a funny story regarding these two. My colleague asked once this question during an interview, like basically what's the difference between row number and rank? And somebody said, like, row number is just an upwards counting sequence which numbers the results with an upwards counting sequence. And rank is like an Olympics. If you have 2 people or 2 values on the same place, the next one is skipped. If you have 3, the 2 next ones are skipped. I have for some reason I have this answer in my mind, and it always comes up when I'm using these. But essentially that's true, right? So now what you can see is we have 2 4s, therefore we have no 5, and it's followed by 6. But if you don't want to have Olympics, but you want to have some kind of logical numbering, right? What's the biggest value in the set and so on, you can say dense rank, and it fixes your problem. So now if we go to, or not a problem, right? But it changes the behavior. So now here we have 4, 4, 6, and now with the dense rank here, you can see 4, 4, 5. So essentially, this is the different behavior, right? So now you can see that, okay, 3 is the 5th largest one. So this is it for the sort of row numbers and so on. By the way, I'm putting these examples in the video description. There will be a link to a GitHub repository that contains this file, among others files from this series. What I think is a frequent use case is you're asked to retrieve like top 3 results from some groups, right? And we have already done that before. Like we have, if you remember, we have retrieved like second largest from a data set. Then it was, with the subqueries, it was complex, difficult. Let's try to do it now, but let's set the bar up higher. Let's say, okay, we want to top 3 in terms of Y value from each fruit color group, right? So what we say is select fruit color Y, just so that we can see it. And then we say row number. What do we say? Over And now we say partition by fruit color. We want to order by y descending because we wanted the highest 3, and we say as group number. So essentially number within the group. And now we say from test table, and we run it. So what we have now, right, is we have currently we only will be able to see the apple and black, right? But here we have a group number, and for the different groups, it will also begin from 1 and so on. So what we have to do now is something very simple, and sadly, I don't know any better way than using a subquery here, but it will be a very simple subquery. I will just select everything, and here I'm selecting everything with an asterisk because here I control the columns that it will return. And here I will just say where group number is lower equals 3, and I will run it. And here if I only remembered about from, we would get the results in the very first iteration. However, here I forgot a comma, therefore we are seeing a little bit weird results. Now it's good. Okay, so now what we have is we have 3 largest y values from each row, or from each group, sorry. Right, so from black apple, we have these, blue apple, we have these, green apple, we have these, and so on and so forth. We have top 3. And it is as simple as that. Now, if you wanted to, for example, go back to our question that we were answering, like when we were doing the subqueries, right? What you could do is you could just say, okay, select star from. Here, let's remove the partition by, because you also can do that, right? You just run it. So currently the partitions don't matter, right? So you can remove it, you can leave them, but they no longer make any difference in our query. We have just now selected the top 3 y values from the whole dataset, which is also pretty useful. And now you just change it right here. Later on we were selecting like the second largest, therefore you run it. You have the second largest row. If you want to know all the values for this particular record, you just say tt.star. All right, and you know all the values, the whole row, which has the second largest y value. You can select the 5th largest. Now you have the 5th largest. Very simple. And last final use case I would like to show you is something that appears a lot when you deal with some stock prices, for example, or with prices of anything in general, or like with maybe you want to track the average number of sales over like a time period, right? And you want to do like a moving average to smooth out some shocks, right? Some big ups and big downs. And this is, to be honest, quite complex with SQL. If you wanted to do it with SQL, this would get crazy with like standard SQL without window functions. Not that window functions are not standard. If you wanted to do it without them, this is getting pretty crazy, right? However, if you want, you can use window functions, and you probably always can. Let's say that we want to have that y is, for example, our like date. Okay, it's not a date currently, but it's just a numeric value, but let's imagine it is. And we want to have like a moving average of x over y, right? And we want to take the actual value we are at and 3 values before that and 3 values after the current x value. And we are talking about the current y value, and we are talking about values of x. So what we would do is we would say sum of x over, and now order by y. So, okay, we are ordering our window by y, and currently our window is the whole result set. And now we will make a limit. We say rows. This means that we will be defining rows with just a numeric value. So we're just saying how many rows before and after. Or to be more specific, we say between. So basically rows between 3 preceding and 3 following. Right? So basically, we make our window consists of rows between the 3 preceding rows and the 3 following rows of the current row, right? So here implicitly of the current row. Let's currently also next to this write an average, right? Here I wrote a sum. It will be much easier for us to validate the result. And here I just had the same over clause and I placed an average, right? So this is our moving average result. I'll just say from test table. And let's currently inspect this, although it will be pretty hard to inspect because currently these values are very big, right? But what you can essentially see is that this sum, it's not like it's always going up, right? So here you can see, for example, it begins with 4, and here we have like 40, and here we have 36, right? And this average is also not going up. Here we have like 63, and here we have 48, and here we have 49. Okay, currently it's looking not very nice, so let's round these values up, and let's run this once again. And here you can see that we have just generated moving average. Super simple, like took us, to be honest, like 2 slightly more complex rows, which are very simple once you understand the syntax which stands behind it. And you can do it. Of course, I did not go with you through all the functions, through all the window functions. Please refer to the documentation of your DBMS that you are using. I can leave you the Oracle documentation in the description of the video. And there are also many more options that you can use, right? So I have just went over the major groups of options, right? So we have talked about the partition by, order by, and then about the rows here. And there are some more options, especially when it comes to these rows. You can specify like a range, and here you have some options to create the window essentially. But I think what I've showed you will cover most of your use cases, and I believe will make your work much easier. So once again, there will be a link to this file we have just created in the description of the video. This will be a link to GitHub. You can just download the file from there. And for now, I would like to thank you all for watching. If you like the video, please leave a like. If you want to see more like this, please write me a comment with what you would like to see, or just write a comment that I would like more of such videos, and I will come with something up. I will come up with something. But for now, thank you all for watching, and I will see you in the next video.